presentation, we're going to get right into wellness. I wanted to say a couple of things as we get started here, and one of them is that I really enjoyed the water quality presentation, and it was fun to hear Scott Gonerman talking about all the things that he's doing. That seems like sometimes as educators we and research scientists we're not sure that anybody puts anything we say into practice, and it's wonderful to hear that that does happen at times. So yeah, I'm really grateful to hear that. Okay. The other thing is about water quality is that there is actually a lot we can do. We can hold on to way more nitrogen. And so we're going to talk about that. And this is part of the wellness part. So this is the foundation of wellness. We talked about all the things getting to wellness. Now we're going to get into wellness. So this is about food and eating. These are my friends in northern France. This is the foundation of the Basque group in Normandy. And we were having a big picnic on the Golfo de Morbihan. And this is all about food now. So let's talk about food a bit more. First things first, though, you build it, they come. This is David Brandt. We heard a lot of talk about David Brandt. This is David Brandt seeding corn directly into a green cover crop. Why do we do that? I've heard a lot. I mean, when I was in Arkansas, I had one person swearing up and down that you could not seed into green stuff. I know people actually in Nebraska, near Kearney, that actually are seeding into green on their irrigated crops. So, and that's important because on those sand hills, like where we get a lot of sand in parts of Nebraska, we really need to be, working to get that organic matter going ahead. So, seeding into green, not that hard. In fact, it's easier to seed into green than the dry stuff because we don't have any hairpinning, any problems with that. But then afterwards, we can kill it afterwards, and we have a lot of opportunity to kill it afterwards. We can roll it, we can do a lot of other things. But the thing that I want you to know most of all is that soil health is in the hands of the farmers, all farmers, no matter where we are in the world. And we can make our soils come alive, and we are not going to give up yield for that. This is a way that you can soil your undies is actually a real test, a cotton strip test. You can see that women's underwear. I was tired of seeing men's undies all the time, so I decided that I would, be a feminist and actually, yeah, go girls. It turns out that when it says 100% cotton, that is not true. Women's underwear actually has a lot of nylon in it, but you can see that the fungi ate out a lot of the nylon. I left this for 6 weeks in a mulch cover in the orchard, and this one it had no mulch, and you can see the difference. The mulch kept that armor, keeping the soil temperature just right for decomposition, and off we went. And yeah, soil your undies in Oregon, and this is near Iona, Oregon, and this is what happens after a full season when you start doing no-till and you've integrated livestock grazing. So one thing that I can tell you is that nutrient output in agriculture has not been a goal. It's just been about yield. They no really talk about quality or how many nutrients are in there. And only now are we really getting into, oh, wait a minute, agriculture can actually be part of climate change. Woo! We can actually be a part of water quality on both sides of it if we're not careful. And this is how it all started for me. So I was comparing organic and what we call low input, which would now be a little bit more on the regenerative side, all no-till. So all my low inputs are no-till. And we decided that we would compare crop rotation. This last one in pink is continuous wheat. This is the milligrams per kilogram of wheat grain of nutrients. This is the same as ppm, so 267 ppm. Um, so these main nutrients. Now I key in a lot on, and I'm going to move this up. Why is that not there? I'm not, here we are, zinc. I key in a lot on zinc because zinc is really important for cognitive function. And it's being considered one of the mineral nutrients that is deficient in the world right now. We know actually in North America that people are really deficient in magnesium and potassium. So I include all those, but from a world standpoint, zinc is one of the most important of the mineral nutrients that we can consider. So let's look at what happened here. What's with 3 and 4? The only difference here is I have more crops. Here I just have wheat fallow, and wheat sweet clover. So wheat underseeded with sweet clover. This I have wheat underseeded with sweet clover, and then I have 3 other crops. And in here I have an integrated forage in both of these. And in this one I have continuous wheat. And what I want you to see, that what really struck us was here. You put a fallow in here, and all of a sudden, look at the differences. These are significant differences in mineral nutrients when you are just growing a monocrop and you have a fallow. When you add other crops, all of a sudden things really start to even out, and the organics aren't that different from our conventional. This was what really struck me. If we just take both of these and compare them to the others, especially for calcium and for zinc. Um, when you have a mixed forage in your rotation, all of a sudden your nutrients jump way up. We couldn't explain this, but we saw it. I mean, this was a 12-year experiment where we were comparing these. And then with our continuous wheat, we just kind of slowly started to decline. And this was not low input by any means. I mean, we were fertilizing this, and our yields were pretty consistent. We were around 40 bushels to the acre at 15% protein of our wheat. And we compared everything in the wheat year. That's what we did, because that's to keep things consistent. So this is what started us off. This is what started me off on asking questions about how can I build the nutrient density? How can I maintain my yields? And it was also the question is, people often ask me is, well, is organic better than, our conventional stuff? Well, if you have a fallow and you just have wheat fallow, like we do in some areas of North America, then the answer is yes, organic is way better, and your wheat is probably rubbish. Um, Once we get into a real crop rotation, the answer is no. There's hardly any difference at all. And the differences come in mostly with how we manage our crops. Not so much even inputs, but a lot of how we manage. Because you can see here, we manage everything the same way, and all we did was change one thing in the middle of the rotation, and we changed the nutrient density and everything. Not the yield, but just the nutrient density. So how do we grow nutrient dense food and build soil health at the same time and not give up yields? Well, the ingredients to build soil structure, quality organic matter, and biological activity is just really simple. We grow plant roots. It's what we do. You saw this before. This is part of it. And this is part of the water quality issue too, and why farmers can be the answer. We start growing some of these covers, we start adding companions, we start intercropping, and all of a sudden we don't have drawdown and we don't lose things. We actually are really efficient in our water use. That means that we also leave water in the aquifers, which means that we give nature a chance to actually rebuild and recharge. Intermingling of roots is what's really important, because this is what feeds that whole system, is the synergy. What this says, what this graph actually tells us is that when plants are experiencing, when they get into a really nutrient rich patch, both plants, even though they're separated, start figuring it out and they start working together. and they start sending roots into the patch. They're sensing that this has more nutrients and they're sending it in. The mycorrhizas are probably already in there. But this is just another thing to let everybody know. Plants aren't just, plugged into the ground. They are active and they're trying to do their best not to die, and they're trying to do their best to reproduce. So, what's mixed species cropping? That would be the same as intercropping. We pay attention to canopy architecture, rooting patterns. Um, we want to take advantage of all the solar radiation. We want to use nutrients more efficiently. We want to use water more efficiently. And when we do this right, we get more yield in the field from both our crops than we would if we grew them separately. Um, Part of it is that these plants are actually sharing things together. Um, they're suppressing weeds. They are attracting different insects. The crowns are at different heights. The roots are at different heights. Um, so they're actually working together. And if we put a legume in the middle, then we actually get nitrogen, and the whole thing really starts to work really, really well. Um, this is Axton Farms out of Saskatchewan. Um, and these are all the things that he's put together over time. And you can see, I mean, if you look in there, just peas and canola, there's no weeds in there. I mean, we actually, people go, well, if you mix a grass and a broadleaf, I can't spray. Well, that's the whole goal, actually, is to try and smother. It's a smothering thing. So, and even though this is two broadleaves, we could spray for grassy weeds. There are no grassy weeds. And the only thing you need to do with this is seed. You're seeding. Um, this is what it looks like at harvest time. And then that's what it looks like in the bin. Now, the value added here, or the thing that we start to see that we need more of, is that then you have the cleaning effect. You have to separate these. Now, some people got really fancy and they figured, well, you just put it together. Well, you actually have to clean them out. So having seed that's approximately the same size is not going to work very well unless you actually want to seed it the next time, or you want to use it for something else. So you really want to pick things where your sieve size is going to separate them. And I'm going to go back there, because what this has turned into for a number of farmers is, actually another enterprise, a stacked enterprise on their farm, where they've added seed cleaning as a service to the community. You've seen all this. This is how these different plants work. And if we can hold on to the phosphorus, if we can hold on to the nitrogen, if we can release things when we want it and leave them when we don't want it, we can actually, really start to use our nutrients more effectively. And that has got to be our goal. Um, and look at this, if we start in mixed communities, if we start using the biology or that microbiome that comes with our mixed communities, we actually get they actually showed a 16% increase in the crop yields compared when we grew it in a monoculture. So just think about that. This is the one I was telling you, flax and chickpeas. This is the no-brainer one. If you're gonna have a go. And reduce the use of fungicide. And actually, we're getting to the point now where we actually don't really need it. This is Lauren Steinlage in West Union, Iowa. And this is buckwheat and soybeans growing together. This is what we would call a relay crop. And actually, Lauren has done a field day recently, this year, on relay cropping. And so that is available through the NRCS. So you can actually see this. And here it is ripening together. And yeah, he harvests one and then he harvests the other. You've seen this before about maize and soybeans. Well, we kind of took this to the next step, and we've challenged some of our breeders to actually start breeding for intercropping. And this is an experiment in Europe where they are actually, and you can see even in Canada, where they're doing these trials on wheat. We're actually looking for things that will grow between the rows and not affect yields. So here's wheat and lentils. Wheat and lentils work really well. And actually, I really like lentils. Lentils like to be seeded in the cool, but they ripen in the heat. Um, and the wheat actually holds them up. And so then they pot out higher. So then it's much easier to harvest them. So that's another option. And there they are. And again, we know that the legumes are contributing at least 15% of the nitrogen to that cereal. So think about the savings, the money in our pocket, the reduced cost of production when we do these things. And this is about getting a nitrogen shot in the growing season or as we're growing. So instead of having to go out in the field, use your tractor, actually do some kind of top dressing. We don't need to because we're already side dressing with our companion crop. I put in some pasture stuff because I'm sure that there's some people in here that have integrated livestock, and so this is the first experiment for Simon here. He's a dairyman, and he just went and bought some floor sweepings and threw them in the field. And I'll admit that I didn't know what was going to happen here when we did this little experiment, but we it was really very much in strips. So what we did is we dug between the strips and then we dug in the strip just to see what it was like. Um, and I have that later on, I guess. And you've seen this, so we're going to go past that. Here we are. So this is what happened. This is between the cut where we had the integrated, we had our diversity, and this is where we had our diversity. And this just happened in 1 year. So somebody asked me, how fast can this happen? This was amazing. This happened in one growing season. We went from this to this in one growing season. We had to get the biggest guy to dig this out. I was I was standing on the spade. It was like a pogo stick, jumping around on it. And because I couldn't get in the ground. And then so we had the biggest guy go in there and he put it in the ground, got this out. Then he went to do this and he just about fell off the shovel because it just went straight in. And again, in one growing season, this is what can happen. This is how we can change old pastures. We can renew them, just seed right into them. And this is about green seeding again. Now, there is one caveat to all of this. You need to have a disc drill. Single disc opener is probably easier, or you need to have a planter with a disc. But tine stuff doesn't work in this. It just doesn't really work very well. And I threw this in here just as a benefit to other people. Too often when we're growing wheat, we're growing corn, and we're growing other things, we don't think about sulfur very much. Now, we haven't had to because we've had enough acid rain and sulfur in our atmosphere that we haven't had to worry. But this is about what we can do with technology if we really want to. We haven't had problems with acid rain for probably 20 years because of the technology that scrubs sulfur out of stacks, which means that for the first time, a generation of farmers have had to add sulfur in and around Eastern United States and Canada. There's been 2 generations of farmers that have never known about adding sulfur, actually 3. And now all of a sudden this generation is adding sulfur and they're not used to it. But it's really, really important because it's the only way plants absolutely positively need a lot of sulfur in order to defend themselves. The other thing is if you're growing wheat, we need a lot of sulfur to make protein in wheat. We can't do it without the sulfur. And if you don't have a lot of sulfur at the beginning, then that also predetermines yield. So That's a really important thing to think about. Um, and part of this, I bring this up, is because now we're back into the pasture management, because that's in pastures too. We have to put the sulfur back in. I use a lot of elemental sulfur, um, broadcast or in furrow. I seed most of my crops with 10 to 15 pounds to the acre of elemental sulfur in furrow, um, just to make sure that the bacteria, the populations of bacteria that turn sulfur into sulfate, are always active and turned on in my soils. So I am always managing to make sure that I have adequate sulfur. Um, this is pasture management with a difference. So this is a multi-spirit species pasture, no till, but we didn't get the plant species right. We didn't have good irrigation. We didn't schedule the irrigation well. Um, you'll see these are plant parasitic pathogens, nematodes. And look what happened here. We didn't get it right. Sure, we had multi-species. We're no-till, but man, we really hit it with the pathogens, pathogenic nematodes. Now we come over here. We had it right. No-till, correct plant species. We had good irrigation scheduling. And wow, look what happened here. Now all of a sudden we have bacteriivores. We have actually beneficial nematodes and only a small portion of pathogenic nematodes. So what we can do with a pasture, what we can do in our fields, some of it's just managing things correctly, managing our irrigation correctly. This goes back to water quality, folks. Um, Thinking about, right now we have the technology to control individual nozzles. So if we're on a slope, I can actually control, make sure that I am not over watering at the bottom and watering enough at the top. And I can also control my end gun as I'm going out towards the end. And especially if I'm on a downward slope, I can actually close off the lower nozzles and increase the ones at the top, the pressure at the top. So I'm watering more evenly. There's a lot of, it's not just about the plants, but there's a lot of things that we can do with technology to actually make this better. Um, and horseradish. I want to. You can tell from the way this is written. This is a South African study we did, and one of my Afrikaans farmers was like, I really like horseradish. I think it's a powerful plant. Maybe we should actually try horseradish. Um, it was really interesting. I mean, it didn't change the percentage of plant parasitic nematodes, but what it did was it really increased the number of predatory ones. And when we say predatory ones, it means predators on insects, on insect larvae. It just totally did that. Now, horseradish is a fairly aggressive plant. It's perennial. So I wouldn't just generally just like, oh, I can annihilate I can increase predators and do this. But I think this is a really valid study. If you're struggling with like soybean nematodes, um, then this is the kind of thing to think about, is actually get this done so you can look at what are the changes. And if you're struggling with corn rootworm, actually look at this, because corn sends out signals. It sends out a signal that says, I want more of these guys to prey on the insects that are feeding on my roots. So what we need to do is actually make sure these guys are around. So maybe that means that we do need to put things between the rows just to make sure they're there and on call when we need them. And plant nutrition is absolutely critical. Micronutrients, trace elements, we need these. Excess N, if you have excess N, and we've been talking about excess N in the water, if you have excess N and you don't have enough manganese and zinc, you're going to have fatal infections. You are. It's just plain and simple. And this goes for people too. We need to keep our manganese and zinc and our selenium up so we can fight COVID. Companions or covers or forage, whatever you want. This is winter canola. And I grew a companion crop with my winter canola. I actually had 90% survival of my winter canola, and I lost everything without the cover crop. And you see these big stalks here. These are mustard stalks. I was using these to catch snow. I was also had faba beans in there because they make really black stalks. You can't really see them here. And the idea was that they would increase the melt and the temperature, so the water would go down better and we'd melt off. So we didn't have that problem with temperature that we often do. We Everybody's like, we this comes back to our nitrogen issue again. We can recycle nitrogen. We can do it. There is a problem, like Tatiana said, there is a problem with getting to the Vedos. We There's very few plant roots that'll go down that far, and it's also, if they do, it's really toxic. So we want to actually start not having things sit and park themselves in the Vedos. We want to make sure that they get mineralized and churned out before they get there. And this is one of the things to think about that we can do. This is my first experiment with companions. This is what I talked about earlier. So these are Desi chickpeas, and I put them with my wheat. This is dryland wheat agriculture in Eastern Washington. So I'm in a 12 to 15-inch rainfall zone. And, you know, it was a rough year. It was a 9-inch rainfall year. But I did 47 bushels to the acre of spring wheat, DNS at 15% protein, on 20 pounds of nitrogen with just chickpeas in between. No herbicides, no nothing. So a lot of my neighbors didn't make much money, but I did. And they said, well, it doesn't look like much. And, it looks a bit rough. Got all these weeds in between the rows. And actually, I didn't have weeds. I just had a lot of chickpeas. And I did have a bit of greening. So I did get a bit of dock because they grew a little taller than I thought they would. But, in the end, I still made money in what would be considered a sort of bad year. And DNS is hard to grow. And a lot of farmers no longer grow DNS and the high protein wheats because just can't afford the nitrogen. I mean, a lot of wheat farmers are putting on more nitrogen on wheat than they are on corn. Like, how does that work? It doesn't. It doesn't pay. We got to think about that before we do this. These chickpeas were cheap by comparison. So, I'm going to talk a little. I didn't get the photo in here of, for some reason, it didn't want to come in. The photo of the alfalfa and the corn. But corn and alfalfa love each other. Like, and I mean, absolutely love each other. And mineral and the transfer through the mycorrhizal hyphae works brilliantly with corn and alfalfa. What it is, we're not really sure, but they love each other. Look at these nodules on this faba bean. This is more of a close-up of what I showed you before. And this durum wheat. I mean, we're still working it out. This was a half rate of faba beans and a full rate of the DNS. We're still working on this one, but we definitely could have gone full rate of faba beans and done a good job. And there were no chemicals on that one. Nothing. No herbicides, because of course we had a broadleaf in there. No herbicides. There was a little bit of fertilizer on the wheat, startup fertilizer, and then we didn't want to. We wanted to make sure that it nodulated. So, we were at the 20-pound mark, and off we went. This was an excellent crop of durum wheat. In the end, a marginal crop of faba beans, but who really cares? We were just really after the durum. And again, the only thing we spent money on was the faba beans, the seed. So now we get to something all of you know more about. This is corn. And you can see no companions here, with companions here. And look at the change in the rooting. There's a lot more roots. There's more happening in between here. That's what we want. Companions, it's just a better deal, and we're not affecting yield. We do this right, no yield effects. This is Chris Teachout again in in southern Iowa, very close to Nebraska City. Um, and this was an experiment that they did with the um, practical farmers of Iowa. And we had guar and mung beans in there. In the end, now he puts in a mix of a bunch of things. Um, this is what they look like. This is an example of the, a general example of what the cobs look like. This is the Three Sisters. This was surprising. That is a really nice cob. I mean, it is. This is the pigeon peas. And you can see these are the two that we really filled right to the bottom. Cowpeas wasn't far behind. The sun hemp was an issue, but the deer ate up the sun hemp. I mean, they ate it up. We never really had much sun hemp, and I don't think they fixed much nitrogen because, man, they were gone. All that corn went, the average of each of the corn that you saw there, they all averaged between 230 to 300 bushels to the acre on dry land. And these are beans here, so we're just going to ignore this. But these are the values here. You can see Three Sisters, just, about the same. We'll go to phosphorus, a lot higher for phosphorus. Sulfur, actually, the guar and the sun hemp were really big on sulfur. Potassium, again, a lot of people are really deficient in potassium. And what stood out here was the guar and the sun hemp. Calcium, once again, pigeon peas and sun hemp. You can see it was different. So that what we had in between the rows was actually affecting the nutrient density of that crop quite a bit. And even though the sun hemp was changing things, it actually wasn't growing a whole lot. It actually had a big effect. So we're putting sun hemp in all the time now. The idea behind this, companions, is to have something to eat if you're integrated livestock grazing. It's to suppress weeds. It's to prevent erosion. It's whatever you need. If you want weed control, if you want disease, it's about what you grow between your rows is really, don't just grow it. Ask yourself, what do you want to do? What is your goal in doing this? And then actually try and pick plants or get somebody else to pick plants that will do that. I didn't want to leave vegetables out. This is onions. And this is sweet alyssum. Yeah, you've seen that in the garden boxes. Wonderful pollinator, stays close to the ground, doesn't really affect the onions, but you just don't get thrips on your onions when you do this. This is pest control for nematodes. This is in Washington, central Washington, in the Columbia Basin. This is under irrigation. This, what you see here, is not dust, it's mustard gas. This is a mustard mustard sorghum crop. It's like 3 species of mustard with some sorghum Sudan. And we grow it, we seed it at about 120 pounds to the acre. We have no nematodes. I mean, we just don't. I mean, that's a problem too, because we don't have a lot of beneficial ones either. But we really hold a lot of sulfur, which is really good because our main crop is onions. This is and potatoes and that. And so, I mean, this just really preps the ground for what we need. All done no-till, and then we mow or we roll and really reduce the tillage in organics. This is organic onions. This is, again, we go into small grains. This is some work that I've done where we're increasing the nutrient density in the subsequent crop. So this comes back into covers. And we were looking, these are all the things we chose. And you can see that we have only 2 or we have 3. We don't have like the fancy 7s or 8s or 12s or whatever. But this made a difference. And one thing we did learn is never, ever, ever use chicory, ever. Chicory stays around forever. It's deep rooted. It has a lot of benefits. It's excellent for pollinators. And if you want to make a pollinator strip, or you're interested in quail or chickens, then it's great. As long as it stays around the edge. Moving in the field, yeah, it's like not even any amount of Roundup's going to get this guy. So these are some of our cover crops that we used before our wheat. And our goal was to grow nitrogen. So what we wanted was like this, 1-for-1. For every pound of biomass we grew, we wanted a pound of nitrogen. So we were really looking for something like this. You can see we did fairly well. These are ones with chicory, and yeah, yields were really, they sucked on that. And this is our subsequent crop, which was a hard red spring wheat. And this is what happened after it. These are our yields in bushels per acre. And this is the yield in kilograms. And then I give you some idea. Things really changed. Now I'm going to go back to those mixes. And I think I have them here. So we look at 9 was the 1-to-1, subclover, sorghum, Sudan, and buckwheat. We go back here. The one that really had the highest mineral nutrient density except for iron was 6. So let's look at 6 here. Faba beans, peas, and oats. We didn't have to get very fancy in order to do this. And this is in an 8-inch rainfall zone. So again, I fear if I can do it, anybody can. This, I talked about phosphorus before. We need to pay attention to phosphorus. It's an important thing in living tissues. It drives membrane. So if we want to have membrane integrity in everything, we need to have enough phosphorus. This is genetics, and genetics matter. There's no questions asked here. This is, we had 480 accessions of peas, and you can see the diversity in iron uptake, zinc uptake, manganese, and copper. We need to pay attention to these, because maybe instead of, maybe we need to find the one that is balanced with good yield and nutrient density and flavor, or some of the other characteristics we want, and go from there. This is Quinn Organics. This is a variety trial. You hear a lot of talk about heritage wheats and how they're so much better than the modern ones. Well, that really isn't true. We had Turkish wheats. We had 52 different accessions of wheat, and we really saw a big difference in the genetics. Now, if you just look here, I haven't got everything on here, but if you look here, we have it grown in the same soil under exactly the same conditions, grown exactly the same way, and look at the differences in nutrient density, and tell me genetics don't matter. Bob and I are actively working on this experiment. I'm really working on digesting it and writing it up. We've done more work on it now, trying to understand what this means. We've got 82 accessions of Turkish wheat now that we've worked on, and we're really showing that genetics matter. But this is what's important about this is we always grow one variety. Maybe we need to actually mix up the varieties and that give a little diversity there too, and start, actually blending some of these things. So, I've been talking to some millers about things like this, because I think this is important. We moved beyond food scarcity, and we had this discussion before. I think we actually have moved beyond food scarcity, and now how can we make our food supply really good for us? And I think that's where we are now. There's another reason plants can heal people. I'm not going to let you study all this, but you can see that there's a lot we can do. There's a lot of things in a lot of these things. Why do I put collards and daikon radishes and things and weird things in my mixes? Because they make a difference. And if I'm going to feed my girls, my dairy cattle, or my cattle, or my sheep, or my pigs something really good, then I want it to be really good for them. I want it to heal them as well as make them fat and ready for market. For those of you who like to sprout things, there's a difference even in sprouts. These are radish sprouts. This is very popular in Japan. Smart radish is actually a variety that's sold for cover crops. Carwoody is also, it's a really good radish for um, cleaning out nematodes. And then this is Tony's radish, and then just common seed. And this is myrosinase, which is an enzyme that's really, really important in the production of sulforaphane, which fights cancer. And they're actually using this at Johns Hopkins. And you can see that in 7 days, common seed, it just really doesn't really work very well. And smart radish and Tony's radish was actually bred for Johns Hopkins. You can see it works really, really well. So genetics matter. I chose zinc to really as my indicator of how well we're doing when we do nutrient density. This doesn't, if you're not really into, um, this sort of biochemistry, then this isn't going to make a lot of sense to you. But what this says is that zinc controls your ability to fight disease. So zinc is the gatekeeper for iron. It and selenium keep the gate. So you're either going to fight diseases with iron, or you're going to take iron out of your bloodstream. But you need to have zinc and selenium and iron and all of these things. And you can get it from food. And we can make it better in food if we want. Um, but plants also heal us. I mean, morphine, all of these different secondary metabolites that come from plants and how they fight disease are things that have actually, we've known for thousands of years. Food pharmacy, this is real, people, and we don't hear a lot about it. But right now in California, Alameda County, for example, and Oakland, they are actually giving people certificates for food. So for pre-diabetics, to help them get over so they don't need the drugs. Drew Ramsey, who's a nutritional psychiatrist, is fighting depression with kale and looking at various nutrients in order to fight disease. So, and fight depression, which is something a lot more people are suffering from these days. So maybe I don't know, I'm not a big kale fan, but I might need to eat kale after being inside from COVID more. And then I wanted to talk just briefly about how we measure things. This is X-ray fluorescence. It's a portable tool. And I'm working with people at MIT right now to build more really good portable tools, handheld tools. This is how we started. This is Faisal, 14th century painting. This is Faisal in his mineral nutrient portrait. This is a leaf. This leaf has had, I use this leaf instead of a banana leaf. But we started doing this in bananas and seeing that we really struggling with chloride toxicity in leaves. Many of you will not know that deficiency symptoms and toxicity symptoms are pretty much exactly the same in plants. So sometimes we're thinking, oh man, that's a deficiency. You should probably do a tissue test to see if it actually isn't toxicity. But here's what happens. We start seeing potassium deficiency in bananas all the time, but we're also using a lot of potassium chloride. So look at the potassium here. What is it ringing out? Chloride. The tips of the leaves are all dying. They're almost solid chloride. And it's not until we get rid of that chloride that the potassium goes back to being used in the leaf. So what do we do? We keep throwing on potassium chloride, and really it's not doing anything. It's just the potassium is trying to protect the leaf from the chloride. So now we have the tools to actually visualize some of these things and start making real decisions. And that's real time. This is just another view of what this potassium is doing. We can do food. We're looking at potatoes, and you can see some of the differences between the inside and the skin. Surprising, a lot of sulfur in potatoes, more than we thought. These are the people who have helped me over time. Naomi Flint is a graduate student at BYU who is doing a lot of the work on iron and inflammation and selenium right now. This is a group of farmers, Shepherd's Grain farmers, that have actually embraced social media in a big way and are using food bloggers when they make announcements about their flour and their baked goods. And then I want to remind you all that once again, when you're standing on your ground, you're really standing on another world. No questions asked. And so I'm going to stop here and invite your questions.
Chris, I'll turn it over to me. Okay, we do have a question from the online listeners. Dr. Clapperton, when the nitrogen is measured from the companion crops to aid the main crop in season, how and when is it measured? Even though we saw nodules fixing from the cowpeas, forage soy, and sweet clover interseeded into corn, we weren't able to see any nitrogen difference from a soil test compared to the check. How and when would you recommend we measure this?
Okay, I recommend that you measure it in tissue. You're not going to see it in your soil test. You're going to see it in the tissue test. So I actually do a lot of tissue testing. I do soil testing about once every 4 or 5 years, and I do tissue testing all the time because I believe that my plants are the best indicators of what they need. They're the best indicators of what I have in my soil. So I recommend that you get a tissue test done and just see how, and then also check to make sure that you actually have nodules. That's the other thing a lot of people don't do is check to make sure they have nodules. Because sometimes if you have a lot of residual nitrogen, you will, legumes are lazy. And the bacteria that form the nodules commit suicide when they form a nodule. So they actually won't do it unless they need to. So, you want to make sure you don't want to be using a lot of nitrogen if you want to have nodules. So tissue testing, lots of tissue testing.
I am not at the site myself. Dan, are there any questions from in the room?
Sorry, we had a technical difficulty and lost connection to the Zoom for the last several minutes. So everybody's taking a quick coffee break. So I'm going to bring this back up. Really sorry about that, Jill.
No, that's okay.
Suddenly the internet just blinked out here. So
I was worried my internet was going to blink out because it kept getting messages about internet being unstable, which is unusual because I'm on fiber optic, but
this is probably a ways away from what we've been talking about, but in this area that I work in here in Nebraska, there's a lot of anhydrous ammonia, nitrogen applied, and just want some comments from you about the impact on the microbial population.
Anhydrous is tricky. If anhydrous burns you, so it burns everything else. So what happens with anhydrous ammonia is that it kills everything in its path, and then what happens is all the organisms kind of move back in and recolonize that area. I went away from anhydrous. I know a lot of farmers in my area are still using anhydrous. It's cheap, but I get a better bang for my buck with solution 32 and ammonium sulfate. So because I can use less and get more, so I'm all about using less and getting more. And I think anhydrous. The other thing is anhydrous was used to make, it hardens your soil, changes the structure. if you're going to get away from it, I think it's a good thing. And it certainly does affect earthworms and soil fauna. I mean, they just don't exist in soils that have had a lot of anhydrous. They come back later in the year, but if for the beginning when we need them to keep our plants healthy and our young seedlings going, we lose them.